Good morning, everybody. We'll go ahead and get started. Want to welcome everybody to our Striker CAD CAM and Nesting Live webinar. What you're going to see today is a result of our attendance at FABTECH just a couple of weeks ago, where we showed some of the latest and greatest in Striker technology that we have out. We had an overwhelming response from people saying, hey, we missed out on the demonstration. We'd like others to see it, or we'd like to see it again. So decided to do this in a online format, and we appreciate all of you guys joining us. Let's jump in and let me introduce everybody that we've got on the call. Our webinar team today, and who's going to be going through the bulk of the material, is Mike Boggs. Mike is the Vice President and Sales Manager of Striker Systems. Mike's been with the company 35 plus years and is probably regarded as one of the experts in sheet metal CAD CAM and nesting software. Mike is intimately familiar with our products and services, and glad to have him leading us today. Myself, Darren Sweat. Most of you have met me either in person or talked to me on the telephone over the years. I've been in this industry a long time as well. And then we've got Danielle Lindsay, who is our marketing manager. Danielle has coordinated this webinar and event for us. You guys may see marketing materials and information coming out from Striker from time to time, Danielle's name on it. Today, we hope to go through everything in 45 minutes or so. So before we do, I want to cover a little bit of information as why Striker Systems. Why are you guys on the call? What do we represent? And how did we get here? So Striker is a leader in CAD CAM and nesting services. We've been doing this just about as long as anybody else that's out there in the industry. The development of our products is very customer centric. We derive all of our new features and our functionality almost exclusively from customer feedback and requests. Customers come to us and say, this is what we need, this is what we want. We work hard to put that into our products. Decades of experience. It speaks volumes about the company that we are, in that we are approaching our 40th anniversary, which makes us one of the oldest in this industry. We've definitely learned by experience. We cut our teeth in the punching world before moving over and supporting lasers as the growth of lasers has proliferated out in the marketplace. All that being said, we still do just as much punching today as we do profile cutting, and we do it very well. We built our product on what is considered to be an industry standard. Back when we developed this platform 40 years ago, we standardized on an underlying AutoCAD OEM platform where we get to focus on the features and technologies and functionality that we're putting into sheet metal cutting and punching, and not into worrying about the graphics and the commands and the ribbon bars and toolbars of our platform. We were able to build on this underlying AutoCAD OEM engine, and it has allowed us to also be compatible with more CAD software packages that are out there. So if you're a user of SolidWorks, Solid Edge, or Autodesk Inventor, we have interfaces that tie directly in there because everybody, of course, wants to be able to play in the AutoCAD sandbox, and we've capitalized on that. World-class customer service is what Striker is all about, and we view customer service as being more than just a department. It's our mission as a whole is to lead by example in what we do in terms of customer support. We have a dedicated help desk that can help you with any issues about your product, whether it be trying to cut or punch, whether it be something that you perceive as a setting of the software, a glitch, or you just can't make the software do what you want to do. We have a dedicated team that's behind the scenes ready to assist you. They are accessible by a direct email access and within the application itself. So when you're using Striker software and you want to request technical support, you can do it inside our software and get straight to us. When we say rapid response time, that's something that we probably take more pride in than anything, because we know that time is money out in this industry. If I told you that we would respond in 24 hours, most people would say, hey, that's good. In the Striker world, a 24-hour response time is not good. We have worked hard to achieve a goal that we are committed to of a 2-hour or less response time, which is unheard of in the industry. When I started in this industry long ago, Most technical support and customer service response timeframes were being measured in days, if not weeks. We still hear that today in the industry and from our competitors, and we pride ourselves on being able to be responsive to our customers that are out there. We offer a same-day response for all of our requests that come in by 5 p.m. So on the same day that you have an issue, we're going to get back to you with that initial response. And to give you a little more insight into how we view our technical support and customer service, is we monitor what our response timeframes are. And I'm proud to tell you that for the last year, our actual average response time is somewhere below 50 minutes. And I challenge you to find anybody else out there in the industry that is able to offer a response time and help customers get back on their feet and moving forward in that fast of a time. We do all of this out of one facility. We don't outsource any of our technical support or customer service. It's all based out of our corporate office, which is just outside of Nashville, Tennessee, in White House. Seamlessly interfacing with all machines is what we are all about. We are machine manufacturer neutral. It doesn't matter if you're using an Amada, a Trump, a Bystronic, an ArcLight, or any of the other machine tools that are out there and available. We're not married to any one of them. We provide you with an opportunity to not have to run multiple software packages to run multiple machines. So you may hear us being offered by certain machine tool companies as their standard software or software of choice. Again, that is just an alliance that we have with them. It's the same software that we offer commercially available to every company that's out there, but providing a single solution for all cutting and punching machines, whether it be a laser, plasma, water jet, 3-axis router, or CNC turret punch, is what we're all about. So my dad used to say there's something to be said about a company that provides you with one throat to choke if you need action. And that's what we try to be here. So know that that's what we're going to go through today, is talking about our cutting and punching applications. When it comes to Striker software in the industry, we provide one of the better returns on investment that you can find, and absolutely the best cost to benefit ratio that's out there. So as a 40-year-old company, we've been able to maintain low overhead, which has allowed us to provide a solution that's at a price point that's better than all of our competitors that are out there. Does that mean we're the cheapest? No. Does it mean we're the best value? Absolutely. We see on a regular basis companies that purchase a new machine tool and they get OEM software provided to them, or so they think, free of charge, where when they dig into the quote, OEM software for a particular machine, we see prices range from $15,000 to $20,000 to $25,000 for a single license, where Striker comes in below half that amount on a regular basis. So it makes it easier to justify Striker inside of businesses, and makes it easier to show a quick return on an investment that's out there. Our integration and interfaces with existing business and engineering systems that are out there, MRP, ERP systems that are out there, we don't get down into the weeds and tied up with specific hooks to access those platforms. We have an open-ended Nest MSE module that we can use to help you communicate with those platforms, and we can certainly support you and help you with your existing systems and tying it all together. From a licensing perspective, we're about as flexible as they come that's out there. We offer a perpetual license. Now, many companies have moved to a subscription-based only license. I refer to those as a rental license, where you must pay to continue to keep the software running, and if you don't pay, the license doesn't work anymore. Striker is not on with that ideology. We do offer it as an option, should that be what you desire. Subscription license, it's not our standard offering, but if there is a need for you to have software just for a short interim period of time that you want to license for a particular job or a project, we can do a subscription base for it. So talk with us about those if you have that need to arise. But we also offer what many companies refer to as a network or a floating license. So to accommodate multiple users, you don't always have to buy multiple licenses of software, because there may not be an overlapping need to have multiple users running the software at the same time. So with our LAN support option with Striker software, you have the ability to load our software on 5, 10, or 100 workstations and be throttled only by the number of licenses to run simultaneously as you have purchased. So if you purchased a single license, one single user at a time can run the software, but they can log out and somebody on another computer can use that. So I say all that. There's not many companies that are around that can say they've got a 40-year track record, and Striker does, and we're proud of that, and you'll see a lot out of us in the coming year celebrating and touting our 40 years as a leader in this industry. We're pretty proud of that. We've maintained our stature as a privately held corporation. You heard me say earlier, we're based out of White House, Tennessee, which is just about 20 miles north of Nashville. We've maintained our independence, and our loyalty is really to our customers. We kind of joke that every year that we attend FABTECH, it's almost like a family reunion. The companies that are coming around with us and coming to talk with us that have dealt with us for 20, 30 or more years. And our competitors that are out there over the years have had a different course of action. Many of them have either folded or been gobbled up. A lot of them have been consolidated in with other packages, other conglomerate software companies, and a lot of them have been purchased, quite honestly, by some of the machine tool manufacturers to merge into their software platform. So a company that previously had software supporting brand X of a machine, their software company was purchased by brand Y, and no longer can they add machines to that software or offer support. So we're pretty proud of remaining middle ground and being able to help customers in any application that's out there. So the main reason that you guys have joined us today is live demonstration. I'm going to turn this over to Mike, where we're going to go through both our punching and our profile cutting and nesting applications in the software, and then we will wrap up shortly after. So I'm going to try to hand the screen over to Mike.
Yep, thank you, Darren.
Thank you, Mike.
Can you see my screen?
I do. I see a cabinet, it looks like.
Well, it's actually an HVAC unit, which, by the way, that's from one of our customers, Hastings HVAC, which they said we could use it for demonstrations. So shout out to Hastings. And what you're looking at here is you're looking at just a SolidWorks assembly, and we'll get started and show you some of that interface into SolidWorks and Autodesk Inventor and so on here in a minute. But before we do that, I'm going to go ahead and launch our Striker 2025 software. Okay, and as it comes up, you'll notice it says powered by Autodesk AutoCAD OEM, as Darren mentioned. And I'm going to say I want to start a new session. And the first thing it's going to do is it's going to stop and give me an option of selecting whatever machine I want to program for. Now, I use this computer for demonstrations, so I have a bunch of different machines out here. All those punches, all these different cutting machines. So we're going to start with punch. Now, we're going to go through both punching, cutting, nesting, and I will tell you that we're going to hit some of the highlights. We don't have time to dig into this. Literally, I've done software demonstrations that take 3-4 hours if somebody really wants to get into the weeds on it. We won't have time to do that, but we are going to hit the highlights of everything. I want to start with punching. And I looked through everybody who was registered and signed up, and there were a lot of you who said that you're doing punching as well as cutting. I wasn't sure whether there would be or not. So I'm going to grab an Amada EMK, pretty standard machine out there. We'll go with that. And as that comes up, I will say, so you're looking at the layout here, and you'll notice that I've got kind of a dark background. I've got a gray background on the ribbon bar, black background out here. Be aware you can change all of that. It's just personal preference. Some people prefer a light background out here and lighten up their ribbon bar and toolbars and so on. And when it comes up, then it has a representation of the table. So I've got the red area, which represents just the travel range, the table of the machine. And then I've got the blue rectangle, which if I hover over that, that is just the default sheet size that I'm working with. Now, one of the things that I want to talk about here before we actually dive into the punching aspect of it, and we'll spend a little bit of time on punching, and then I know there's a lot of you that have lasers, and it's like, okay, so how are we going to nest for our lasers? And we're going to get into that here just momentarily. But But one of the considerations is, so where do your parts come from? Okay, so are you a job shop where you're just getting parts from customers and that's all you're dealing with all day long is I'm getting parts that are coming in as a DXF file on a paper napkin? Or are you more of an OEM and everything is being designed in-house? Striker Systems can adapt to whatever means that is, but a couple of the considerations is that we do have a part library system that can help to facilitate that. And it's not something that you have to use. I will say, you know, if you want to just keep all your parts out in a directory structure and work out of that, you can do that. But there are some advantages to this part library system. And if we look up here, what I've got loaded is I've got the Striker Systems punch tab. Okay, so this is all of my punching commands. And on here, I have what we refer to as part share. This is a networked library system. So if you've got multiple licenses of Striker software, then everybody who is running the software would be looking at the same thing. And if I open this up, you'll see I've got my part libraries tab here on the left. And as I kind of scroll down through that, you'll see that I've got parts out here in every one of these libraries. Now, you can think of this kind of like a directory structure, and what you name these is totally up to you. So I can do a right click and create a new library, rename libraries, delete libraries. I can drag parts from one library to another, so it's very flexible. But one of the advantages of working through here is if I look at this Hastings HVAC directory, and I've got it sorted out by customer. You may do it based on product line, by customer, or you may just have everything in one part library. But if I go in and double click on something, then it brings up the information associated with that part, and I've got my part number, description, but I also have my material information, and these fields here can all be customized. So I've got project status, drawn by, drawn date, and all of this information can be automatically populated in a number of different ways. But how do you get the parts in here? Well, there's several different ways of getting parts in here. One is that you will see an import queue right here, which allows me to import parts. I can batch import DXF files, DWG files. I can batch import SolidWorks models, Autodesk Inventor models, Solid Edge models, a number of different options. And one of the things that we do offer is this part share library, which when we're nesting, ultimately, this is where it's looking to get the parts from. But when we do it from SolidWorks, one of the options with part share library is that it is available as an add-in for SolidWorks, Autodesk Inventor, Solid Edge, some of the more popular modeling systems that are out there. So here I have the assembly from Hastings HVAC, and you'll see that we add a tab into the ribbon system. And on here is Striker Part Share, just like we were looking at it a second ago. Now, if I open this up, well, it looks just like what I was looking at. Now, a consideration here is that in my case, I'm running this on the same computer. So the Striker CAD/CAM software and this SolidWorks, I'm running on the same computer. But be aware it doesn't have to be that way. So you may have, 1, 2, 3 licenses of CAD/CAM software that are being used for programming. You may have 5, 6, 7 licenses of SolidWorks or Autodesk Inventor, whatever your modeling system is. It's being used in engineering. Well, this part share add-in is available just as an additional little plug-in or add-in into SolidWorks that can run totally independent of the rest of the Striker software, so that a SolidWorks engineer would be able to go through the same process of adding parts, assemblies into the part share library, just as I'm about to do here, without having the rest of the Striker CAD/CAM software. Now, that being said, if you do have one of these modeling systems on the computer that you install the Striker CAD/CAM software on, it will detect that during the Striker installation and will install this add-in automatically. Now, you will notice that I have my part libraries tab here. I also have an assemblies tab, because one of the things that the part share library does honor is bringing assemblies across from one of these modeling systems. So if you look here, This assembly is actually the one that I currently have open. So this assembly has already been extracted. For time's sake, I'm not going to go through the process of extracting this entire assembly. But what I am going to do is I'm going to say, hey, I've had some revisions to some of the parts that are in this assembly. So rather than pulling the whole thing, which I would say new if I'm going to pull the entire assembly, I'm going to do what we call a check-in. And what that does is it brings up a list of here's all of the parts that make up that assembly. Those that are sheet metal parts are active. And if I go double click on one of those, you will see that, well, it is actually populating all of that information from within the SolidWorks properties. Same thing true with the other modeling systems. Now over here, you will see that there is a status, and the status says use existing. Now it says use existing because it's detected that, hey, all of these parts are already out there. We're updating this assembly, but by default, and this is just a personal setting that I have on here, I'm going to say I want to use the existing parts that are already out there unless I override that column. Okay, I could have it by default say, hey, update all those parts. But I'm going to say, you know what, I got this subassembly here. Let's assume that I got a couple of the parts on that subassembly that have been updated, some revision to them. So I'm going to say I want to update the subassembly, and it tells me, okay, it's going to update those parts. So when I OK that, then those parts are taken and the flat is generated and dumped out just as you would go through more interactively, except it does it in a batch process, automated, and it pulls all of those part properties and populates the database. Now, so this is the subassembly that I pulled. So if I went and said, hey, I want to look at the advanced properties in that subassembly, then I see down here that it was just now updated during the check-in of that assembly. And that is a consideration. The part share library does fully support part rev level. So if you're doing revision tracking, whether that's an actual revision field or whether that's just using the modified version of the part number by tagging a revision onto the end of it, it'll support all of that, but it also does allow you to do what I just did and say, hey, I want to update and overwrite this part. If you do that, be aware that in the background, we keep a running history of all of those parts. Every one of these is a different version where I've extracted that. There's the initial one that I did, looks like I did it yesterday. So I could come in and say, hey, I want to insert any one of these previous revisions. So just be aware we do keep a running history of that, so we don't make it real easy for you to just like overwrite a part. Now, so that is one way of getting the parts out there. Now I'm going to close out of SolidWorks and back to Striker. And another way, and again, I can batch import a bunch of stuff, DXF files, DWG files. So I'm going to come here to this import queue. And what I did just a second ago from SolidWorks is I said, hey, I want to open SolidWorks and then I want to release parts to manufacturing. So basically I'm pushing them across from SolidWorks. Now in this case, I'm going to come to this import queue and I'm going to say, hey, I need to import some parts. So I'm going to say new. And here I actually have some Autodesk Inventor parts. So if I went and grabbed these Autodesk Inventor parts and said, and I'm going to go and select the specific library that I want them to go into so we know where they are. I'm going to grab these parts and say, hey, these are just Autodesk Inventor parts. A customer sent them to me, and I'm going to say I want to import those. Now, it's actually using Inventor in the background, just kind of launches it virtually and goes through and pulls those parts. So 4 parts successfully imported, and if I look, then there's those 4 parts that have been added to the part share library. So a bunch of different ways. And one that I haven't mentioned, which I probably should, is that up here is our Striker Systems Design tab. And because we are built on an underlying AutoCAD engine, we do have significant design capability. In fact, this product is the same product. What we use as our underlying platform is the same product that Autodesk uses as their AutoCAD LT software. It's got a different skin on it, but in the core, it's the same product. Now, we do have some customers. I mean, the vast majority of our customers have moved on to some 3D modeling system, but we do have some that use this as their primary design system. Also, it does allow for if you are bringing parts in from customers, and as you know, you get parts and they're not quite as clean as you would like them to be. You get corners that don't match, overlapping objects, and so on. There are a ton of utilities that we won't get into right here for going in and automatically identifying and cleaning that stuff up. Now, with that, I am going to take those parts from the assembly that we were just looking at. And you'll see that I actually have a tooled version of these parts out here. I meant to get rid of those before we started this. So I'm going to say, hey, I want to filter down to everything that's tooled up for this Amada. And then I'm going to say, hey, I just want to get rid of all those because we're going to redo that. So in here, I'm looking at all the parts of that assembly. And one thing about punching, so punching is a little bit of a different animal in that when you are doing programming for punching, there's kind of two different philosophies. One is that you apply tooling to all of the parts ahead of time and make sure that you have everything exactly the way you want it and have tooling consistency and so on. And the other, and there's something else I thought I had changed. That's all right. We'll do that real quick. I'm going to change a toggle. I've got it set to more of an interactive process, but that's okay. We'll just change it real quick. I do not want to insert with interactive nesting. We'll look at interactive nesting in a minute. So I'm just going to drop all of these parts in out here in my workspace. It doesn't matter where. Okay. So this is a new project I have. I've got to tool this up. And what I'm going to do is I'm going to tool it and I'm going to save it back off. Now, be aware that Striker CAD/CAM software does have the ability that I can pre-apply tools to these, and then anytime in the future I'm working with the tooled version of it, or if this is a one-off and I'm never going to see these again, maybe I want to allow it to dynamically tool these through the process. It absolutely can do that as well. But what I'm going to do is I'm going to go ahead and tool them as they are. And this is the tooling setup. So this is my turret. And over here on this side, this is all of my different tool libraries. So I've got my standard tools, round tools, rectangles, special tools, square tools, rolling tools, bow tie tools. So any kind of tool that you can come up with, we can use. Now, this is where it's getting the tooling information from. But what I'm going to do is I'm going to use this Striker Systems punch command. And I'm just going to say, you know, if I pick a part, then okay, I process it in there. I've tooled up a part. But what I'm going to do is I'm going to run that command and I'm just going to throw a window around the whole thing and let it process all of them. And in this dialog, there are things that I can change as to how I want it to tool. So for example, do I want it to automatically tab the parts as it's doing it, or am I going to come back and do that after the fact? If there's text on the parts, how do I want to process that? Do I have a scribing tool? Do I have a dot matrix kind of marking tool? Okay. And do I want to allow it to search the tool cribs or the tool libraries, or work just with the tools in the turret? So a number of options here, but I'm going to go ahead and process. And all of the tools are placed and the parts are tabbed and ready to go. If I'm looking at this and I'm like, well, they're tabbed, but they're kind of hard to see. Well, in the tabbing, I could real quick say, hey, you know what, I want to go in and display all of my tabs so I can look and see, all right, so that's where they are. And then if I needed to take a couple of these tabs out or add some more tabs in, it's something that's real easy to do. Now, one of the things that we do recommend, and some of you have been punching for a while will I'm sure remember this, is that it wasn't too long ago that the automatic tooling process, the tool fit options in these software products just wasn't that good. And what you ended up doing is you ended up using a lot of the manual punching commands like these up here of doing single tool hits, and I want to punch that line, and basically going through one object at a time. So they've gotten a lot better, and I would say that Striker Systems has probably the best auto tooling process on the market, because we've been doing it for a lot of years. But still, I'll be the first to say that when it comes to punching, there's not a system out there that's going to punch every part the way you want it 100% of the time. It's just not going to happen. There's too many variables. So if you did have to go in and change something, we recommend that you auto tool it, and then we make it real easy to go in and, hey, I need to make a change to something. So let's look at a specific part. And let's say that I need to fill up a sheet with this particular part. So if I look at this, I see, all right, so if I hover over here, I've got, what is that? That's a 1 by 1/4 inch rectangle. It's in an auto index station. Here I've got a 1/2 inch square. Well, maybe I want to use this 1/2 inch square to punch that corner out. Because I can, if I'm just running this single part, I can get rid of a tool change. So I'm going to use this command right here, replace edge hits, which is a very versatile command. I could use that and say, well, you know what? I want to punch these real quick. And okay, so got rid of that tool. And maybe like this tool right here, which if I hover it over it, I've got a 3/8 inch round. Let's say that for whatever reason, I got to pull that tool out. Maybe I broke the tool or the tool's out for maintenance. Up here, I got a 281 round. Well, I could say replace edge hits and say, you know what? I need to nibble that out. And I could use the same command here to go in and adjust the scallop height and so on. So very versatile. So if you do have to make any changes, it's quick and easy to do. Even if I had to change the geometry and still say, hey, you know, I need to use that command to punch something that I've changed on it. Now, once I've got these punched the way that I want them, and I want to save these things off, it is a matter of just saying, hey, let's add these parts back into the part library. And if I look in my part share library, I now see that I have a flat instance and a tooled instance of all of these parts out here. So I've got tooling consistency moving forward, and these parts are linked. The flat part and the tooled part are linked. So any changes that are pushed through, you are notified of that. Okay, now how do I get those laid out on the sheet? Well, there's a few different ways of how to do it. So I'm going to start with kind of an auto nesting process, and then with punching, I know a lot of our punching customers do some interactive stuff, so then I'll show you some interactive stuff as well. So I'm going to start by going into our Nest Wizard. And this brings up this dialog. Each one of these different folders here is a nest job or a nest kit, okay? Which, when it boils down to it, it's nothing more than a list of parts and quantities. At its core, it's a list of parts and quantities. So there's a lot of other information that can go in there, but at its core, that's what it is. So how do you get the parts and quantities in there? Well, a bunch of different ways. In this case, I'm going to say, hey, I want to do a right click and say I want to create a new kit. And here we'll just do an 001 as a kit number to get started. And it brings me into this dialog, and this is my active kit creation dialog. The top portion of this is where I would get parts from. The bottom portion of this is where I would build the list of parts that I want to have in here. So if I look, I've got my part libraries. Okay, so here's all those different part libraries that we were looking at, and I can go in and go to any particular part library. Also assemblies. So I said we do support assemblies. We looked at that assembly coming from SolidWorks. There's some other options in here, some predefined clusters. You can add a kit into a kit. So if you have a kit that you always run multiple times in different quantities, you can create a new kit and say, hey, I need to take this one that I previously created and add it in there, but give it a quantity of 10. There's an import, which there's a number of different import options here, which we'll look at in a minute, but for things like batch importing DXF, DWG files, CSV files, we'll look at in a second. But what I'm going to do is I'm going to come back over here to my part libraries, or I'm sorry, to my assemblies, and I'm going to grab this one, the one we were just working on, the one we just tooled up, and I'm going to drag it down here and say, okay, I need to manufacture 3 of that assembly. I can assign a due date to it. Work order information. These work in process fields right here can be labeled whatever you want. So that might be customer, it might be routing number, just whatever you wanted to put down here. And this is just information that travels with the parts through the life of the nest. Now, if I okay that, then down here I have all of my parts. And it is just a matter of saying, all right, I'm done with that one. Let's go ahead and close that out. So do I want to calculate it? Yes, I do. and let that run. So we see the layouts that are being created. And if I open this up, you'll see it opens in kind of a hierarchy. And you'll see subjob 1, subjob 2, subjob 3. Okay. The reason for that is because each one of these subjobs is a different material thickness. Okay. So I obviously can't nest parts that are of a different material or gauge on the same nest. So it automatically sorts those out. And then if I open these up a little bit farther, then I can drill down to, okay, so here's the individual layouts that were created. Okay. In this case, first two subjobs took one layout, and then the third subjob looks like it took 5 layouts. Now, and I could drill all the way down to the individual parts if I want to drill down to the individual parts. Now, if I look at this layout, so it is it's a decent looking layout. And one thing that I failed to mention is that when I calculated these, I actually had a toggle turned on that told the nesting algorithm to go and look at the available sheet sizes that I have in my sheet list and select the sheet size that's going to give me the best material utilization. So in this case, it selected, let's see, a 4x10 sheet. If I look at subjob 2, yep, a 4x10 sheet. If I look at subjob 3, it's like a 5x10 sheet. And if I look at this, it did a pretty good job. However, I do have some space down here, and you run into that a lot in nesting. You just don't have enough parts or part mix to fill the sheet. So how do you handle that? Well, it may be that you're charging this entire sheet to the customer, so it doesn't matter. You just let it go. However, if I did want to take advantage of that, several different ways of how I could do it. I could drop this layout in and manually kind of put some parts in there. There's also a feature where I can just do a right click on it. And if I have a part that I want to say, all right, so I know this is a part that's, it's an inventory part, it's a repair part, it's whatever. We keep some of these on the shelf. So I'm going to go into say, all right, I want to add filler part. And then it's going to show me only those parts that are of the correct material type gauge that would fit on there. So I could go in and say, all right, so I know I need some of this part. Maybe it's a part from another job, and we'll let it go ahead and fill that out. Now, when I get to this point, I am going to say, all right, I'm good with that layout. I'm good with this layout. So I'm ready to go ahead and process those. To do that, it would just be a matter of clicking on those and saying, all right, I want to go ahead and get code generated off of those. So I'm going to do what we refer to as auto NC selected. So those that I've turned on here, let's generate a program off of that. Now, a lot goes on in this process on a punch. Because one, you'll notice I got an oversized sheet here, so it's going to have to do a reposition. So it drops those in, it makes sure the tools are all sequenced correctly. It does repositioning analysis, it does toolpath optimization, and it does generation of the NC code. So you see these are now turned yellow now, which is telling me, and I do have a legend over here, so it's telling me the job's in process, the NC code has been generated. So if I do a right click on here, I could say view NC code. So there we have the code that we've generated off of that, and it's ready to be uploaded to the machine. And also, if I said, hey, I want to look at my reports, I'm going to go to my report, and I'll just do a view of it rather than a print. But we provide the software provide you with a lot of standard report templates, but you do have the ability that we can go in and change these for you, modify these for you if one of our templates doesn't exactly do the job for you. But if I open this up, this is a pretty standard one. So it's just going to tell me my overall kit name. This is subjob 2 of 3, what the overall material utilization is down to the individual layouts, telling me what the material utilization is, the sheet size to be used, what the parts are that are on there, quantities, etc., and then down to the estimated runtime on that sheet, clamp locations, and what tooling is used on that. Okay. And we can, on these reports, we do have the ability to have it automatically create these reports for you and just create them as like a PDF file and dump those out for you. Now, so that was going through and auto-generating a nest. What I'm going to do now is because a lot of our customers will do something that's a little bit more interactive on a punch. So I'm going to go through and do something that is a little bit more interactive, and I'm going to flip that toggle back that I had on before, which was for more of doing an interactive nest. And what I'm going to do is I'm going to go back into PartShare, and I'm going to filter, and PartShare has a ton of filtering capability. So I'm going to say, hey, I want to filter by this field. So I'm saying I want to filter on all the tools or all the parts that are tooled for this particular machine. And this may have 1,000 parts in here, so this filtering really comes in handy. And now I want to go in and filter down to just the specific material gauge that I want to work with. Okay, so I got 3 parts here. So I'm going to grab this part and say, hey, I just want to insert this. And I'm going to do a right click and do what we call one of our iNest commands. So if I fly out here on my right click, I've got iNest move, iNest copy, and these are interactive nest. Well, I'm going to do an interactive nest grid, and I'm going to drag this part out and say, hey, I want to do, say, that many of that particular part. And then we'll grab another one and do the same thing. We'll drop it in here, and it is keeping my spacing and allowing me to butt parts up against each other as I do that. So I'll do a right click on that. And same thing, say I want to do an interactive nest grid. And then finally one more, we'll grab this part. And drop it in and do the same interactive nest grid on that, okay? And you know what, as I get this thing out here and I see, well, actually, I could get that part gridded up there as well. So let's throw some up there. Okay, so I've got the part laid out here. Now, when I was in the nesting engine, I basically hit one button and said process this, and it went through all of the process of doing the tool sequencing, the repositioning, the toolpath optimization, generation of code. It just did all of that. Now, if I wanted to be more involved in that process, maybe I need to override something, or I've got some forming tools that I'm using and I want to be very, very cautious of exactly what my toolpath ordering is, then I can intervene and work on any of these processes. So for example, in my tool sequencing, there it's showing me my tools. I'm going to tell it to reorder just based on all of the settings that I have on exactly how I want these tools ordered. But if I wanted to go in and change something, so for example, if I wanted to take this tool, which I got a 3/4 inch at 0 degrees, that same 3/4 inch at 90 degrees in an auto index station, and I could drag those things up and down and move them wherever I want them. I can take and break tool sequences or portions of an existing tool sequence out into a new tool sequence here, which those of you who have punched before, you know, there's reasons why you might want to do that at different times. But I'm going to go ahead and close that out. And then repositioning. So there are some repositioning commands here, auto repo, quick repo, different options there. I'll select this one, which says, all right, I'm going to reposition. I'm going from left to right. I could change that, go from right to left. But there is, do I want to automatically position the clamps based on the settings that I have for clamps, or do I have stationary clamps and I want to just leave them there? So when I OK that, clamps are positioned. You see my work holders come down. There is a reposition indicator down here, and we're ready to go with that. So there's one more piece of this, and that is, okay, so toolpath optimization. So there's a bunch of optimization functions right here, and I'll tell you, you could take this all the way down to, I just want to pick those tool hits in the order that I want them, if you want to go to that level. But I'm going to go into what we refer to as our workflow wizard. And this has a lot of different functions, but one is kind of a simulator, and it does give access to my tool sequencing, my tool path optimization, my auto repositioning, generation of NC code, all from just within this dialog. So if I look at this and say, all right, well, so what am I looking at on position 1? So on position 1, it's going to punch all of that, and then it does a repo, and then it's going to punch all of that. If I want to override that, I can move tool hits from one position to another. And then if you look down here, you'll see it says the travel length is 9,687 inches, okay? So I'm gonna do a reposition, or I'm sorry, an optimization, and I can do an optimization of any individual tool sequence or select multiple tool sequences, or in this case, I'm gonna say optimize all. And then there's some different settings up here. Now, when it comes to optimizing for cutting or punching, but punching in particular, but cutting as well, you can't just say, hey, I want to optimize this tool sequence and I want to start with this hit and go next closest, next closest, next closest, because you could find yourself that, okay, so, you know, you got tool hits scattered around, so it starts up here and then it ends up snaking down here, and you optimized a strip through the center of your sheet and didn't optimize anything else. So the sheet has to be looked at in different sections, and different software products handle that differently. What we do is we break the sheet up into rows and columns based on the kind of tools it is, the tool sequence, and we refer to that as banding. So basically I can create as many rows and columns for optimizing any individual tool sequence. And in this case, I'm going to turn this on and say auto band and let the system go in and figure it out. And it looks at every tool sequence, and then it runs through over 100 iterations of, okay, so what's going to be the best banding method to go vertical, horizontal, how many bands, and comes up with the optimum. So if I okay this, you'll see that the travel length decreases by 51%, goes from 9,000 some inches down to 4,000 some inches. Now, if I wanted to look at any of that, I could select any individual tool sequence and look at it, or in this case, I'll just hit play, and you see, okay, so I could sit here and watch the whole thing and see, all right, is that what it's doing? Or I could grab any individual tool sequence and look at that. I do have the individual ability, if I said pause that I can just kind of step through, forward, back, etc., just to validate. And again, when you start getting into a lot of things in punching, be it forming tools, different special tool considerations, louvers, etc., you need to be very cautious of your tool sequencing. Now, if I'm good with this, again, I could just say write NC file, and just as we did before, there we have the code that we just generated, and just as we did before, even though I did not go through the nesting interface at all, if I said I want to view a setup sheet, and this is a little bit more of a standard kind of more generic setup sheet, but gives me all of the information necessary for setup for that particular job. Okay, now with that, we are going to move off of punching, and we're going to move on to profile cutting for a second. So I'm going to come up here and just say, hey, I want to start a new session. This time, I'm going to scroll down, and here I've got all these different cutting machines, and I'm going to grab an Amada Insys, only because we have done so many of those machines here over the last few years. So I'll grab an Amada Insys, very common. We okay that. The workspace layout looks very similar, except I just don't have my work clamps down here. And then how we approach this from a cutting standpoint, a laser generally is much easier to program than a punch, okay? Because you don't have to deal with all the different tooling considerations and forming considerations and rolling tool considerations and how are you going to handle text considerations and so on. So it's just a matter of, I got to put a tool path on here. I have to make sure that I'm using the correct cut conditions based on the material type and gauge that I'm running, and what type of lead in and lead out, where's it going to be, and tool path optimization, and there you go. So unlike in punching, where if I look in part share and clear all my filters, I've got all of these parts pre-tooled for the Amada EMK. With a laser, I'm gonna just let it dynamically process these. Now, that being said, you don't have to. If you wanted to do the same thing with a laser that I did here and pre-apply the tool path, you can do that. If you had a part that was very critical on where the lead goes, and if you're doing any micro joints, shaker tabs on it, where those go, then you could pre-apply the tool path, file it off in here, and it would work the same way. Now, there's also more automated methods of using the nesting software than what I showed in the punching demonstration. And I'm going to come over here and I'm going to go to Nest, and I'm going to grab this MRP import process. Now we call it MRP import process because kind of old school, but I'm going to import a file that would be typical of what would be exported from like the scheduling module of your ERP software, MRP software. But in reality, it's just a CSV file. Okay, so I've got this one called FABTECH Nest, because as Darren said, this was a demonstration that we originally put together for FABTECH. But to show you what's in here, I'm going to do a right click and just say, hey, I want to open this with Excel. And of course, it came up on my other screen, but that's okay. We'll drag it over here. And I said at the beginning that with a nest, it's really at its core part numbers and quantities. Okay, and if we look at this, here I have my part number field, here I have my quantity field. However, there's a ton of other stuff that we can bring along. So revision field, although I've got it blanked out because I'm not using revisions, work order field, and in this case, we talked about a little bit about filler part and being able to say, hey, I want to fill up a sheet with an extra part. So that is something that can be designated on the front end of the nest, and you'll see there are a couple of these where I do have the quantity that I want, but then I have a maximum quantity saying, you know what, this part is one that we do use a lot. It's used across multiple jobs. We do keep an inventory of those. So I'm going to allow it to run up to an additional amount if it would improve material utilization. And then I have a due date on here, work center. So I don't have a work center on here because I'm keeping this thing kind of generic. All right, so that's what's actually in that file, and be aware there's a couple dozen other fields that can be configured in here to just accommodate whatever information you want to carry with that part. So I'm going to close out of that, and then I'm just going to double click on here and let it run. Okay, so that was called FABTECH Nest. So I'm going to minimize that nest that we were in. I'll go to FABTECH Nest. You'll see it was only one sub job. It is for an Amada Insys. And in this case, it did create several layouts. And if we look at these, again, down here, it tells me what my material utilization is, sheet size that was selected, or in this case, I think I just had a standard 4x8 sheet. But just like in Punch, if I'm ready to generate a program, if I look at these layouts and okay, I'm good with that one, I know I'm good with that one, then let's go ahead and generate programs off of those. It would be just a matter of doing that same auto NC selected. Now, at this point, it's going to drop it in, apply the tool path to all the parts. If there's any shaker tabs, micro joints that are going to be applied, it will do that. There is a complete auto tabbing system in here that will allow it to do that based on the XY size of the part to control tipping. It is looking up all of the cut conditions on here based on the material type, material gauge. And if we open that up, just like with Punch, they're turned yellow now. I can see the original layout, and I can also see the processed view, although it doesn't really show me much other than it's colored in red, showing me that it has been processed. And if I wanted to view the NC code, okay, so there's code that was just generated for the laser. And just like with Punch, if I said, hey, I want to go in and view or open up one of the reports that was generated. Okay, so it's a little different report. It shows all of the individual parts, so I see what the quantity is on this layout of the total quantity, and so on. And again, down to what the estimated runtime is on that. Now, as I look down through these layouts, we get down to the end and we see this one, which again, this is pretty typical, just like on the nest, of, well, it didn't fill up that sheet. Well, I didn't have enough parts to fill up that sheet. So what do I want to do with it? So I could do filler parts, just like what we did in Punch. But one thing that is a little bit more common on laser cutting is doing a remnant cut and basically saving that off and using it in a different nest. And we're going to do that real quick. So if I come to one, and this is just the way that I have the software configured to automatically detect once I get up to a certain size of, hey, I got this much space available, I'm going to say, go ahead and process that. So it drops it in. But this time, when it applies the tool path to the parts, it comes back and says, oh, I got a remnant in here. Do I want to go ahead and define that remnant, and drops the remnant cut in there to cut that off? Yes, I do. So then it assigns a remnant number, just a unique ID to that remnant, so we can find it out on the shop floor. And I can control exactly how I want it oriented for any future nesting operations. And if I wanted to override this and type in whatever I wanted there as a remnant number, I can absolutely do that. But when I OK that, you'll also see up here in the corner that it took and it applied the remnant number to the edge of the sheet, to the edge of that remnant sheet, and etched it on there. Okay, so you don't have to worry about writing something on there with a Sharpie or tagging it. It was actually done for you. Now, so I created that remnant, and if I wanted to use that remnant, I'm going to create another nest. So I'm going to say, hey, create kit, and I'll we'll just do an 002 on that. And just like we did before, now again, I could go in here and I could grab the individual parts and so on. So I'm going to use this import, and just like we imported that CSV file a minute ago, but I imported it and told it just run and create the nest. But maybe what you're going to do is every order that you have a CSV file created for just the parts in that work order. And then somewhere through the process, there's a decision of, hey, I'm gonna mix these work orders together. So I could come in here and say, hey, I want to import a file, and if I've got a work order out here, I'm going to grab it, and it's going to say, hey, yep, I found all those parts, we're ready to go with that. If for whatever reason there was a failure, which often is because, hey, you don't have the correct version of that part out there, then it would be highlighted in red, and I could just do a right click on it and say, all right, I need to view the status on that. But I'm going to say, all right, those were all good, let's add those in there. And then I'm going to say, I want to import another one, grab that one, and add it in there. Okay, so now I've created my list of parts here. But by default, it's either going to use a standard sheet number, or it's going to use a auto selection mode where it'll go in and select what would be the optimum sheet. So I'm going to come in here in my nest details, and we see here's all of the different standard sheet sizes that I have available for this particular material type and gauge. But what I want to do is come over to this tab, which is remnants. And if we look down through here, this is the remnant that we just created. So I'm just going to say, hey, I want to add that into this job. And I'm going to make sure that it's positioned first, because I want it to look at that first. And as it works off, if you add parts or sheets in here, then it's going to work those off in the order that they're in there. Now, be aware that you do have the ability to turn on a toggle that says, anytime I run a specific material type and gauge, always look to see, is there a remnant sheet available or sheets available that can be used? And if so, consume those first before going on to a standard sheet size. But in this case, I'm just kind of manually adding it in there. So if I close that out and say, yep, we want to go ahead and process that. And if we look at it, so there was, looks like 4 layouts created. And if we look at it, then it consumed that remnant sheet first and then continued on with a standard sheet size. Now, just one other thing I wanted to show you here. Well, a couple other things real quick, and then we'll wrap up because I know we're a little bit long. We're right at an hour. So if I come back down here to this FABTECH nest and we look at this, and I had generated programs off of a few of these layouts. So if I do a right click on this, one of the modules that we offer is a little costing module, which isn't anything like real fancy, but if I open that up, it is going to come back and tell me, okay, so here's the parts that are in that nest. Here's the quantities, weights, the weight with some scrap applied to it, which there's algorithms for that, number of pierces, cut time. It does support punching if you're doing want to do any costing on punching, travel time, total time, and then what the cost is on a per part basis, and the cost, the total cost based on that quantity. Okay, so be aware that this is here, and we're not going to take the time now, but I could drill in here and I could show you all the different setups that it's going to take into consideration. Your laser consumables, it's going to take into consideration your floor space if you want to, your labor, your material, etc. But just be aware that is something that's available. Now, just one other thing I want to show you, and then we are wrapped up. So I'm going to close this for a second. I'm going to minimize this for a second, so we're back to my desktop. And I'm going to drill into right here where I've got nest job data. So like right here, that nest we were just looking at, FABTECH nest. Anytime a nest is created, there is a directory created that has all of the different parts out here now, or all the information that we have about that nest. So I'm going to flip this to details. And I can see I've got PNG files of all the individual parts. I've got images of the layouts. But one of the things that I wanted to show you is that there is also XML data that's created. And that XML data, if you start getting into more of an automated system, that XML data can be very valuable in reconciling back with your ERP system or any other business system where you just need to be able to access certain information. Now, all of these XMLs, there's one created for every layout and every sub job, and it all has some specific information. There's a master one that has everything, and if I open that up and we just kind of scan down through here, you will see it has information about everything that we know about that nest. Okay, so from the overall job down to the individual parts, down to part run times, weights, plating areas, what material was consumed, what the work order numbers are, et cetera. So if you have any other business software that you need to be able to access, we keep this on as neutral a format as possible. So industry standard XML, and very easy to write a script to access any of this information. So just wanted to make sure that you were aware that that is something that's available. And I know we covered a lot in a short period of time. I will say that if you're interested in digging into it more and you want a more detailed demonstration, by all means reach out to us, let us know. And Darren, I'm going to hand this back to you real quick just to close us out.
Great, Mike, thank you very much. Great job going through all of that. Hopefully this was beneficial to everyone out there. We apologize for running a little bit long. I'll take some of the blame for that. Email is up on your screen right now. That sales@strikersystems.com. That gets to all of us. If you want to email me or Mike directly and you have our email address, feel free to do that as well. Thanks a lot for joining and participating. We appreciate it. I hope you guys will give serious consideration to working with Striker Systems, because we'd certainly love to work with you. Thanks a lot, everybody. I hope you have a great day.